We're going to tackle a huge question today, one that every business owner thinks about, from the smallest startup to the biggest corporation. When does it actually make sense to get bigger, and when is staying smaller the smarter move? Let's dive in and try to find the recipe for the perfect size.
So, here it is, the big question. Is bigger always better? You know, we're kind of taught to think that growth is the ultimate goal, that scaling up is what success looks like. But is it really the most efficient way to run things? That's exactly what we're going to unpack.
To get our heads around this, let's use a simple analogy. Baking a cake. It's perfect, right? You've got your ingredients, flour, sugar, all that good stuff. Those are your inputs. And then you have the finished cake. That's your output. Simple enough. But right away, we run into a little problem. Let's call it the baker's dilemma. And this is really the core challenge of scaling any kind of business. I mean, think about it. If you take a recipe for one cake and you just triple everything, do you get a perfect giant cake, or do you get a mess that's, burnt on the outside and totally raw in the middle? See, just throwing more inputs at a problem doesn't guarantee a better result. And that right there, that's the whole idea of efficiency. So to really understand this, we need a kind of blueprint. Let's just quickly break down the language economists use to describe what our bakers are doing. Okay, first up, we have the input. Economists like to call this X. For our baker, this is super simple. It's the bowl of batter, all the ingredients, all mixed up, ready to go into the oven.
And then, of course, you've got the output, which they call Y. And that's the prize at the end of the whole process. It's the delicious finished cake you pull out of the oven.
And what about the magic that turns the batter into the cake? Well, that's called the production function, or f of x. Just think of it as the ultimate foolproof recipe. It's basically a rule that tells you the absolute best cake you can possibly get from any given amount of batter.
Now, here's where it gets really interesting. We can actually draw a picture of that recipe. This curve you see here, that's our production function. Along the bottom, that's our input, how much batter we use. And going up the side, that's our output, how much cake we get. The curve itself shows you the best you can possibly do at any given point.
Okay, so now that we have this blueprint, the real mission is to find that sweet spot, the point where we're being as efficient as we possibly can be. But how do we actually do that? How can we measure how productive our baker is being with any particular batch of ingredients?
We use something called average productivity, or AP. And honestly, it's just a fancy term for a really simple idea. It's your output divided by your input. For our baker, it's literally how much cake you get for every cup of batter you put in. More cake per cup means you're being more productive. Simple as that.
And here's the really cool part. You can see this on the graph. If you draw a straight line from the very beginning, that's the origin, point O, out to any point on our curve, the steepness of that line, its slope, is the average productivity. So a steeper line means you're being way more efficient.
So it follows, right? If we want to find the most productive point, all we have to do is find the steepest possible line we can draw from the origin that just barely kisses our production curve. That one point where it touches, that's our sweet spot. That's where we're getting the most bang for our buck, or the most cake for our batter.
And of course, this magical point of peak efficiency has a name. Economists call it the Technically Optimal Production Scale, or TOPS for short. This is the exact size where any business is running at its absolute most productive. Period.
All right, now that we know what perfect looks like, we can actually build on that. We can create a kind of efficiency scorecard to grade any size of operation.
Because look, knowing the tops is awesome, but what about all the other possibilities? What if our baker makes a much smaller cake, or a way bigger one? Well, now we can actually measure exactly how efficient those other sizes are compared to the absolute best.
And they do it with this formula for scale efficiency. Now, I know it looks a little bit like homework, but I promise the idea behind it is incredibly simple.
All it's really saying is this. Your efficiency score is just your current productivity divided by the best possible productivity you could have. So a score of 1 means you're absolutely nailing it. You're at the tops. Anything less than 1 just tells you how much room for improvement you have.
This all leads us to this really useful concept called returns to scale. So if adding more inputs gives you an even bigger jump in your output, well, that's increasing returns to scale. If you put 1 in and you get 1 out, that's constant returns. But if you start putting more in and getting less and less back for your effort, you've hit diminishing returns to scale. And that's the point where getting bigger is definitely not better.
Okay, so we've talked a lot about theory with cakes and batter.
let's bring this back to the real world and talk about why understanding scale really, truly matters.
And the beauty of this whole idea is how well it applies to everything. The graph on the left is our simple little cake recipe with one input. The one on the right, that's a real business, juggling tons of inputs, like labor and materials. The math might get a little hairier, but the core idea of finding that most efficient scale, it's exactly the same.
So what's the big takeaway from all this? Well, understanding your scale efficiency helps a company make these massive decisions, like whether to expand or even downsize. It tells them their most productive size and gives them a clear benchmark to aim for. And it also explains a lot about the world, like why some industries, say car manufacturing, are dominated by a few huge companies, while others, like craft breweries, are filled with tons of small, successful ones.
So I'll leave you with this final thought. Next time you're in your favorite coffee shop, or a restaurant, or even a giant supermarket, just take a look around and ask yourself, based on what you see, do you think they're running at their perfect scale? Are they too big, too small, or have they totally found their sweet spot?